this video, we show the practices that support ongoing changes in student thinking. The first of the practices is introducing ideas that students can use to reason with in the upcoming activity. This is an interactive form of direct instruction. The second is engaging students with an activity that generates observations or data. The second practice requires that students use the introduced ideas from the previous practice to reason with. The third practice is using this new knowledge to revise models and explanations for the anchoring event. This set of practices would be used 4 or 5 times throughout the middle of a unit to help students make cumulative sense of activities, investigations, and readings. It's important to remember our principal goal for this unit, to develop an evidence-based explanation for why the population of Adelie penguins in the Antarctic is declining. This day's lesson is about the cascade of effects that climate change has on organisms and their ability to compete for resources in a changing environment. Here's an overview of what you'll see. The first practice is introducing ideas to reason with. The ideas for this lesson involved accumulating energy in our atmosphere and in our oceans. In the second teaching practice, our students engage with secondhand data about air temperatures, snowfall, the prevalence of sea ice, and the fluctuating populations of different organisms. We ask our novices to interpret this data in light of ideas presented about the climate. We ask them to think about how high school learners might talk about the graphs, and we ask them to make claims based on the data. In the third teaching practice, we have our novices summarize how they are thinking about the Antarctic ecosystem now, and then return to their current models to make evidence-based adjustments. The lesson begins with me offering a set of ideas that I want students to reason with in an upcoming activity. I presented these ideas at this point for 2 reasons. First, the concept of a climatic feedback loop is not something students could easily discover or construct on their own. Second, we want students to spend most of their time using these climate ideas to reason about their biological consequences. We cut now to an episode after this presentation, where our novice teachers discuss how they might scaffold students' first look at graphs.
Working with kids who perhaps have never thought deeply about what a graph means, or they haven't been able to, they haven't been asked to draw meaning out of a graph or talk about its trends. And so if I were to just help kids break down the meaning of a graph, let's say in a whole class discussion, what are some things that I would ask kids to think about first and second and third?
But in this group we decided explicitly that it was important to direct their attention first to the title, because if you just say what is the graph trying to tell you, they might just look at the data, passing right over the title and right over the axis.
I'm wondering, would you just tell them, hey, state the title, or would you ask them to restate it in their own words? Because if you ask them, okay, what does the title say, that doesn't necessarily mean they're making any sense of what the title says.
What I was trying to get at is we need to determine what our goals are in terms of how should they approach data presented this way. And in our group, we decided that they should avoid the common pitfall of looking at the data first without realizing what's being compared. So the strategy for how they should approach that we discussed was they should know the title of the graph, some version of that, whether it's in their own language or what does the title tell you, and then put their eyes on the axis and understand what's being measured by each axis before they look at the data.
I think one thing we're skipping over is the x-axis. It's obvious to us, but for the kids, I think just focusing on the y-axis and what's being measured is necessary. But I mean, the idea is to find out how that changes over time, and I think you have to draw their attention to that. What if you asked them? These are the results of a big, long experiment study, and talk about how it was done. So what were they trying to find out?
So I have 2 things. One is I've got an information sheet that is like the ones that are up there that you put on your models, but it just reminds you some details about these 3 organisms. And I would urge you to make sure you read every little bulleted point about that organism, because anything could be important and you don't want to skip over it. So this is an information sheet. On this sheet, there are some trends, some graphs that show what population trends are for these organisms. I've got the number of breeding pairs of Adelie penguins taken over a period of probably 35 years. I also have the density of the krill in the area where the Adelies are over time. In the middle, I have a graph about sea ice, which is an abiotic factor. But the first thing I want you to do with this, in number 1 up there, is I want you to read the information and look at the graphs, and I want you to describe to each other in your own words what you think the graphs mean. Then as a group, I want you to talk about this question. How does the amount of sea ice in the Antarctic environment affect the chances of the Adelie penguin to survive? I want you to talk about that. If you struggle a little bit to begin answering that question, I've got some helper questions right here that you can think about on your way to really giving a serious consideration to that question in red. The last thing I want your group to do is to write. So steps 1 and 2 are to look, to read, to talk, and then step 3 is to write. I want you to write a claim which is of course a statement you believe to be true in response to this question. So there's a lot of different statements you could make, claims that you could make about what's affecting the chances, if anything, of the Adelie penguins to survive. You choose what the claim is, but I want you to write it in this form because today we're going to practice just using this idea of evidence.
At this point, 2 of my novices will take on the role of teacher, so I do a quick briefing with them in the hallway. They know by now that a teacher should make a first round of visits to each group, listening intensively at first, then offering a prompt or question that will press students to reason further about the data. The teacher makes a second round of visits later for a different purpose, to prompt students to connect what they are learning in the activity to the bigger science puzzle that is anchoring the whole unit.
Remember, when we go to each of the tables, we're there for about 2 minutes tops each, and you're listening intensively for about 30 seconds. What are they talking about? And then you will either refer to the information sheet or to this. You could point out something that you think that they overlooked.
Or have them elaborate on why they think the graph, or their interpretation of the graph is what it is. Okay. But focusing more on the graph and less on their answer.
Well, I would say equally important. We just want them to understand this really indirect relationship that penguins have with the sea ice. It's really indirect, and there's a couple things in between in that chain. It's a phytoplankton and krill.
Is that a good background question?
Yes, absolutely.
Why do you think these 2 graphs don't match if that's the food?
Yeah.
Do you worry about that confusing them and them just kind of being like, it doesn't make sense?
No. It's real data. Real data.
I know. I'm just wondering.
Some of the, if you have kids in your class, they'll tackle that.
So in a few minutes, I'm going to ask them to try to talk about their statements that they want to make. So that's another thing. In your second round, you can say, tell me about the statement that you're going to make and how you're using the elements, and get them to use those sentence frames.
So we'll do the first round before you do the second round?
So we're talking about the sea ice and the krill, and we noticed that when we were reading about the krill can only grow on the sea ice.
No.
what?
Krill eat phytoplankton,
Oh,
and phytoplankton
phytoplankton.
in the winter, the only place phytoplankton can grow is on the underside of sea ice. So if there's less sea ice, there's less phytoplankton. There's less phytoplankton. There's less krill. Because the krill eat the phytoplankton.
So do you think that maybe there's a graph missing here?
Yeah, I was about to say I want a density phytoplankton graph for things. There's also the
And what
snow.
in the reading can you use to help explain?
The one he added today?
Yeah. Like, what's the snowfall
This
like
overlap.
at this
Have
time?
you guys talked about
And
that at
what's-
all? I'm just curious.
How
How the density of the krill is related to the amount of sea ice? Why?
Or that because of the lifespan of a penguin is much longer than the lifespan of a krill, the population growth in krill can happen very rapidly. and decline very rapidly. So like a big fluctuation in krill is not as significant as it is in penguin.
We were saying that we think this peak is in response, A, to the slight bump and increase in sea ice, and B, to the decline in the predator population. Like, and those two events like coincide and cause this like larger bump.
So if these were not decreasing, and this stayed the same, then this bump would not, this increase would have been
Yes.
So do you think that if the sea ice levels remain constant, would this peak still happen because of this decrease in penguins, or does the sea ice have a role as well? Or a significant?
This does have a significant role.
I would claim they both are dependent on the sea ice. And both populations are reducing at a similar rate that's related to the reduction in sea ice.
And we think that because the only place phytoplankton will grow in the winter is the underside of the sea ice. And that's what is the livelihood of the krill.
So I'm filming myself coming and talking to you guys, prompting you to write that claim. What claim are you guys writing?
So we're writing.
Our grammar's not very good.
Wait, I came up with the claim, I should
All
say.
right. Yes.
Okay.
You know, fix your grammar.
So Paige, why don't you get ready to say the
Okay,
claim?
the-
Marek, why don't you get whatever data or information up so we can refer to it? Go ahead, Paige.
Okay. The fewer kilometers squared of Arctic ice, the fewer numbers of breeding pairs of Adelie penguins will be present.
Yeah. Oh, so we think this because we see downward trends in both the sea ice over the last like 20 years because we didn't really know what to deal with. So we were just looking at like their down. We saw they're both decreasing. And then in our data sheets, our reasoning that connects these two all together is that the phytoplankton that the krill feed on live on the underside of the ice. So when there's less ice, there's less phytoplankton and then less krill, so less penguins.
But it sounds like that's a different and more elaborate claim than Paige said.
They totally keep it simple.
Well, I also, I think
the density of the krill.
if you want to leave out the krill, we also know that Adelie penguins can't swim very quickly
Yeah, so we'll be
to
using
search open water for their food. So if there's less sea ice, there's more open water, and they can't swim very well. So then they wouldn't be able to get their food.
And there's also now more room for like leopard seals to come in and get them.
They're gonna be in the water more.
Right.
Yeah, they have to get food. They're gonna, even though they're not good swimmers, they have to go where the krill is. They have no choice.
Right.
So Parikh, I think you've got a kind of hypothesis about like leopard seals having better access to them when they go out farther, venture out too far. It's another part of what your theory might be.
Okay.
But, so you guys have two different kinds of claims. One is more like an explanation.
I thought that was our reasoning though. Like claim, then evidence is in the graph and reasoning.
Would be like coming from here.
Yeah, reason. Well, no,
If here's
that's
our
not right.
evidence, like our data, then here must be our reason because, well, there's got to be a reason that links our data to what we see.
Yeah, but the whole like krill should have been part of our claim, and our reasoning should have been part of why the trends support our claim.
cut the krill out.
Yeah, because we're not seeing this reflected in the krill data because the spikes and drops in the krill data don't align with what we're seeing in the Adelie penguin population.
The group over here, I'll put my finger over there, the group over there has got an interesting hypothesis about the lifespan of krill being so short that their population, when times are good, can shoot up much more easily than penguin populations can. And also, when times are bad, it can go down super rapidly. So I don't know if that would also figure into your, any part of your claim. We want to keep our claim manageable. Okay? So you guys got to figure out whether your claim should be, as Paige said, a statement about a relationship between two of these graphs, or should your claim be more in the form of the explanation itself?
Okay.
we think that this is what's going on that causes this relationship in the data. I don't care which one you choose. Just pick one, okay?
I'm just saying that this particular species of phytoplankton has evolved in order to be able to exploit the resources that are under the ice that other phytoplankton can't get to because these guys are evolved to be there. So that's why the patterns with the ice.
Now you're seeing how hard it is to do something that's in the next gen standards, which is to use evidence to support an explanation or a claim. You're getting ready to produce a kind of argument, to create a case for something. And I told this group over here that there's a lot of different claims you can make. I don't, at this point, care what the scope of your claim is. It will just be helpful if we hear what everybody's claim is, and then you can all see what kinds of claims each other are making, and then also how you're using evidence. Tina?
If you were in a classroom
Show Tina. Start over, Tina. Yes, Tina.
If you were in a classroom that had more than 13 students, how many of these claims would you end up talking about? Would you give us time for every small group to share?
If I had kids in groups of 4, I might have 7 groups. I could have every group share, and then maybe the task that I would do, as I heard them, is maybe group the claims, and then we could talk about them in groups. It's possible.
Okay.
Yep. So, claim. We think that when there's less sea ice, then there will be less Adelie penguins. Our evidence for this is that when the graph of sea ice decreases at the same time that the graph for the number of Adelie penguins decreases. So that's going down there, and that's going down there. So that was our evidence. And then we also had reason, because it said on here that Adelies can't swim quickly enough to effectively search large stretches of open water, and in the water they're eaten by leopard seals. So our reason was that Adelie penguins can't swim effectively to hunt for food, and they're targets for leopard seals, so that the less ice that there is, the harder it is to find food, and the more likely it is they'll be eaten. So when there's less ice, there'll be less penguins. 30 seconds. Next.
Okay.
Less than 30, I think.
All right, so just a comment by the teacher before, I'm not going to make a lot of comment, but they made a claim about the graphs, and they made a claim that both were going down.
Yeah.
Is that your claim?
No, our claim was that when there is less sea ice, there will be less Adelie penguins. Our evidence was that the graph was going down on both of them. So, which are kind of two different things.
Okay. So that's one kind of claim you can make. Let's see what other claims we have. This group over here with Dennis and company is going to say how your claim is different than Parikh, Tina, and Paige's claim. Why they're different. So you guys got to pay attention.
So our claim is that the amount of Adelie penguin is directly related with the area of sea ice extending from the Antarctic Peninsula. And our evidence is that with the decreasing area of sea ice, the density of krill population is also decreasing. As you can see here, as the area of sea ice is changing or it's decreasing, the density of krill population is also decreasing. So it's the same pattern, as you can see, like the decrease is same. So this leads to a decrease in Adelie penguin population because they feed on krill, which rely on sea ice for their food. So from this information sheet, we got to know that the Adelie penguin rely on krill for their food, which in turn rely on phytoplanktons, which live under sea ice for their food. So it's kind of a interconnection.
Okay, Dennis and company. How was their claim different than the first claim?
So the claim that they made was just about 2 trends in the 2 graphs that they looked at. And the claim that they are making is that they're related?
Directly related.
Directly related?
Yeah.
Paige, do you want to comment on Marie's interpretation of the difference?
I
agree with Marie, I guess I'm saying.
Okay.
We also explained there's a third organism involved, phytoplankton. Actually, they introduced phytoplankton and krill, which the first explanation I don't believe did. So they're showing how it's kind of a food source that is affecting the decrease in the Adelie penguins, whereas the other claim attributed it to predators.
Okay.
All right, so we think that decreasing sea ice means that penguins have to swim in open water more to eat krill, so they're less protected. They're less protected from the leopard seals that we know eat the penguin.
That's what we said.
You just want to be
Well, we weren't going to change it on the fly, so.
So for our evidence, we have the first graph showing the population of breeding, well, the number of breeding pairs of Adelie penguins. There's a general downward trend that sort of corresponds with this second graph, which is the area of sea ice. And so we think that this is good evidence to support our claim. Reasoning? Our reasoning is that for these Adelies to feed, they have to go off of the sea ice into the sea to feed on the krill. We learned that from our little reading here. And so we think that because they have to do that, they're going to have to do that more often when the sea ice area is smaller. They might have to swim a little further out to get to the same regions that they would have been able to easily get to if the ice extended further, you know? And so they're spending maybe more time out in the ocean, which increases the likelihood that they will get preyed upon by the sea leopards.
What?
Leopard seals. Sorry, we call them.
In this lesson, our students have engaged in authentic scientific practices like analyzing and interpreting data, using information to reason about ideas, creating new facets to their explanations, and arguing with evidence about the decline of the Adelie penguin. But we're not done with this set of teaching practices. In the next video, we finish the lesson by having our students return to the drawings of their explanatory models and make changes based on what they know now.